On the 22nd. On the 22nd, this will be a bonus. It is how you create the quadratic formula. And if we can create the quadratic formula, we don't always have to complete the square anymore, because we'll make a formula that does it for us. But this is the question. You have any number in front of x squared. And if you had any number in front of x and any number at the end, in other words, if you had any quadratic equation where a, b, and c can be any whole number or integer, how would you solve this? Let's look at our steps for completing the square. What was step 1? We wanted to get an x squared plus something x on one side, right? What will I have to do? If those were numbers, you'd have to divide everything by a, because that's how you could get an x squared. So I divide this by a, and this by a. Then I would have x squared plus b over ax. Are you okay if I move the c over a to the other side? Okay. That, if I moved it over to the other side,
It becomes
negative c over a. Draw our spaces. This is where recognizing patterns really comes in handy. Because the next thing is you would say, I want to factor this perfectly. This would have to be an x, right? What did we notice about this? Every single time. It's half of it. Dividing by 2 is the same as multiplying by 1/2, right? What happens when you take b over a and multiply it by 1/2? How do you multiply fractions? Don't need a common denominator for multiplying, right? How do I multiply b over a times 1/2? Multiply the tops, multiply the bottoms. Can you see that I would get b over 2a? So this will become plus b over 2a. If that's plus b over 2a, what goes in the green space? Okay, now we're thinking if I had x plus b over 2a times x plus b over 2a, and this is foiled out, what's going to be my last ones when I multiply them? Close. B times b will be not 2b, b squared. Good. It's going to be plus, let me just move my line here a little bit. Still have it down there. B squared, and 2 times 2 is 4, a squared. Can you see that? That b times b would be b squared, and 2a times 2a would be 4a squared. But if I do that on that side, I have to also do that on this side. How do you add fractions? Need a common denominator. What's the common denominator between a and 4a squared? 4a. So I would need to multiply the top and bottom of this by 4a to get 4a squared. Can you see then I would get minus 4ac plus b squared over 4a squared. Now one thing when you're doing this on your test, you're going to have the answer. You're going to have the quadratic formula already. And one thing you're going to notice with this is that in the formula, they rearrange this to do the b squared first minus 4ac. Can you see that that's the same thing, just changing the order of the top two things when we're adding? I put the b squared first instead of the minus 4ac. What's the next step that we would do when we're completing the square? When we get to this? Square root both sides. So now I would get x plus b over 2a equals the square root of this, plus or minus. And right away I'm just going to put the square root of the top, and I'm going to put the whole bottom in a square root too, because that would be the square root of the whole thing. Can you simplify any of those? It would be if it was multiplying, but because it's subtracting, this all gets combined. So normally if the b squared was multiplied here, you could simplify it, but because it's subtracted, we can't. But on the bottom, the bottom is something that you can simplify. So I still have plus or minus b squared minus 4ac on the top, but the bottom can become 2a. You want to get x by itself? What would you have to do that b over 2a? Subtract it. And if you subtract it, do you notice those fractions already have a common denominator? So we can add the tops all over 2a. And this is the famous quadratic formula.